I need to make sure too that we can actually see it. They can see it. Whoever watches this can see it. So I'm about there. Those are just my answers. Okay. Does anybody have any questions about anything though so far? Okay. Let me know if y'all do. If I get the same question over and over again, that's where I'm like, hey, let me make an announcement. So the last thing that we had done was we learned a process to actually list all of our possible zeros, okay? So at the beginning of 3.4, what they did was they gave us a polynomial and they actually told us divide by, right? So that literally told me use this, divide by it, and then again at the beginning, whatever I got down at the bottom of my synthetic division, that was my quotient, that was my answer, right? Whether there was a remainder, whether there wasn't, like no big deal. The goal was, can you synthetically divide, okay? So what you notice in the second half of 3.4 is they don't give you something to divide by. They still give you a polynomial and they actually get a little bit uglier. Honestly, I'm not even a kid. But the only direction is find all zeros. Well, I'm literally not going to randomly pull out numbers because that could take forever. You could get lucky, but because you might not, like, let's not try that. You know what I mean? Instead, what I'm going to do is use what I learned in the last class, which was how can I actually find all of the different numbers that have a possibility of being zero. And I get that not all of them will be zero, but if you have a list of 4, 8, 10 different values, it's way different than you just randomly generating them yourself, right? So what we're going to do is this problem, and the directions only just say find all zeros. So the options are either synthetically divide, and then, hey, we know what to do here, or synthetically divide, synthetically divide. Like you kind of notice it's going to be the same pattern. And the math in between all of these problems isn't hard, but the fact that it's a lot of work, that's what kind of gets confusing, okay? So list my zeros, my possible zeros. The way we do this was we took plus or minus P over Q. And what I mean by plus or minus P over Q, my P is my constant term. Constant meaning there's not a variable attached to it. That'll always be, if this is written in the correct order, that'll always be the very last number. Excuse me. And now what we're going to do is actually do plus or minus, do like kind of a, maybe like a large numerator, like fraction bar. I feel like I'm going to like hiccup somewhere in there. Excuse me, for your P, you take your factors of your constant. So I literally can just do this. It's on the end. It's not interrupting any of my work, right? Let me figure out the factors of 21. Factors of 21 are what multiplies to give you 21, right? We've kind of done this. It's like in the middle or kind of like the beginning of the AC method. I know for a fact 1 times 21 gives me 21, right? 21. And then 3 times 7 also gives me 21. If you keep on, you're going to do 4. No, that wasn't equal, right? They can't equally go into it. You're going to get 5. You're going to get 6. You're going to go back to 7, right? You don't have to write 7 and 3 and 21. You're just done here. Okay, you don't ever write the numbers twice. So for my P in my numerator, I write all of the factors of my constant term. For our Q, that's the leading coefficient. Factor that, write those factors in the denominator. I can't really factor it here, y'all, because it's going to get messy. So I just come over here. Because 3's prime, the only factors that multiply together to give you 3 is just 1 and 3, right? So literally 1 times 3 gives you 3. These factors are written in the denominator, both of them, okay? 1, 3. My kidneys hurt. Oh. Okay, so what we're going to do here is we're actually going to write out. What you do is you use a combination of everything in the numerator and everything in the denominator. You can either do it 1 over 1 and then 1 over 3, or you can list all of the factors of 21 over 1 and then all of the factors of 21 over 3. It doesn't matter. As long as you end up with the same zeros, it really doesn't matter the steps you use right here to get there, okay? I think what I had done, Actually, did I skip a step here? No, I didn't. Okay, so you can do 1 over 1. That's taking this factor and writing it over this factor. And then do 1 over 3, plus or minus 1 over 3. Then scoot over to your 3. You get 3 over 1, and then plus or minus 3 over 3. Plus or minus, now I'm at 7. 7 over 1 and 7 over 3. And then now I'm at 21. 21 over 1 and 21 over 3. So this should be a review-ish from what we did last class. Now, actually looking at all of these and evaluating pretty much what that little rational value is telling me, value 1 over 1, I just get 1, right? So I just have plus or minus 1. I know the plus or minuses can get annoying, but literally we have a positive 1 and a negative 1. So it's very important, like you don't let those just fall off or anything, okay? And then if you look at 1/3, that's already reduced. I can't really math right there. It's just one of the possible zeros is either a positive 1/3 or a negative 1/3, right? Now scoot over to 3 over 1, y'all. That's just 3, right? Anything over 1 is just itself. If I do 3 divided by 3, I get 1, right? In your notes, if you actually write values twice, that's fine. When you go to input them on an exam to like write your final answer or on the homework, it's probably not going to want the same value multiple times. Okay, you would just write it one time. Because 3 over 3 is 1, I already have it. I'm not going to write it. 7 over 1 gives me 7. 7 over 3, that's already reduced as possible, as much as possible. And then 21 over 1 is 21. What's 21 divided by 3? 7. I already have a 7. I'm not going to write it. Again, if you do, that's fine. Honestly, all you're doing is you're making it to where you've got a whole other line to write when you don't include multiple numbers. But it's up to you, okay? I'm completely content with that right there. Okay, so my goal was find all zeros, right? Figure out what the possibilities are that I can divide by. I'm looking for something that when I divide by it, I get a 0 for remainder, right? So literally, you just start with your different possibilities. I started with 1. I did this in the last class too. Christmas makes me sad because it means you're broke. And for some reason, I'm writing all in Christmas colors right now. I'm going to use these possibilities and I'm trying to find a 0, okay? So technically, I just start with positive 1, then negative 1. If they don't work, I just keep moving on. The Descartes rule of signs too, plural. I think in these problems, if you really understand it, it's not confusing, could honestly help because it'll tell you if you have imaginary roots or zeros, same thing. Or if you have how many positives or negatives, it can help, okay? But it's not necessary. Unless it explicitly states to use it, y'all don't have to do it, okay? It's a long shortcut. So, finding zeros. Here are my possibilities. Let's start with 1. I did a long little line because that's a bunch of coefficients in that original polynomial. And yeah, totally crooked line. Okay, so to synthetically divide, we're going to pull all of the coefficients from my original polynomial, the one that I'm working on, not necessarily original per se, because, you know, if you get really deep into a problem, you just need to pull the coefficients of the polynomial that you're working on. Right now, we haven't done anything. We haven't really done any math. This is what we're working on. Those coefficients are 3, a negative 26, a positive 24, a positive 74, and a positive 21. Underneath your last term, you're going to do another little like half box, right? Very first step, very important step, once you get kind of the setup done, is that you pull down this value. Whatever it is, if it's plus, minus, doesn't matter, you bring its entirety down. Okay, so once you do that, now we start doing, I don't really know, I'll probably do a couple like this, but after a while it gets really messy and really ugly. So I won't do the whole thing like it. I can't tell if you can actually differentiate the colors here. I have a blue in my bag. I'm gonna do a couple of steps, okay? Actually showing what I'm doing each time, But like I said, it gets really messy and cluttery, so I'm not going to do it forever. Okay, so pull down your coefficients, write what you're dividing by, right? Bring down that very first term. Now what I do here is multiplication with the product going right here, okay? So if you do 1 times 3, you get 3. So I'm going to write that product in blue so it matches. Gotta love continuity. Now what I do here, after I do the multiplication, I say combine, because it might be add, it might be subtract. I'm just making add and subtract one word, okay? Depending on the signs, that's how you know what to do. Using my calculator, if I don't want to think that much, I'm going to put the positive number in first. 3 minus 26, what do you get, right? I usually talk in the way of, you don't need your calculator if you say the sing-songy stuff I say, okay? Signs are different. So what you do is you subtract. Oh, I need red. Going down this way, this is me combining, okay? These signs are different. So what you do is subtract, and I would get 23. You keep the sign of the larger. So hopefully visually, this might clear up some confusion, okay? So now I'm gonna do my blue again, which I'm gonna multiply what I'm dividing by with what I got here. I do 1 times this negative 23, my product goes here. 1 times 23 is 23, right? The signs are different, so I get a negative 23. And then for this column, what I do is I combine. Those signs are different, so what I do is subtract, and I keep the sign of the larger. Now, you do the multiplication. You take what you're dividing by, and you multiply it by what you found here. Your product goes right here. 1 times 1 is 1. Signs are the same, so it's positive. Here, you combine. 75 and 1, those are both positive. You just add and keep. It just becomes a positive 75, right? Add them, keep their sign. Okay, now I'm gonna tell you right now, you do this enough because the homework already requires you to do a lot of practice and you want to do great on your exam, maybe because you did or didn't do well in the first, like this is where you can recover yourself. If you've gotten to a certain point, you know for a fact it's not gonna equal 0 here, you can just move on, okay? After a while, it'll start becoming a little bit more clear about in this area. So like I'll notice, I'll look down, I haven't even done half the work because I can already see where it's going, okay? So, but continuing, I do my 1 times my 75, my product goes here. 1 times 75 is 75. Signs are the same, so it's a positive 75. Right here, I combine. Those are both positive. I would just add them. 7, 8, 9, I get 96. Honestly, I don't even care what's here. The fact that it's not 0, I move on, okay? 1 is not a 0 of this polynomial. So it can't even be written in a factored form. It literally means nothing for this problem. Move on. Does that make sense? Okay, so I'm done with all the colors. Give me anxiety, more than I already have. Okay, so 1 didn't work. I need to try a different number. I usually just like a book, right? I did positive 1, now let's try negative 1. I feel like this used to be angled differently. That maybe? Zero difference. It's awesome. I'm using that piece of paper. So when I synthetically divide again, because the first possible 0 that I tried ended up not being a 0, every single thing that I set up is exactly the same, except for now instead of a positive 1, I'm trying negative 1. Okay, don't get confused and think, oh, I'm doing negative 1 and that it affects anything here in your list of coefficients, because it doesn't, okay? It's just what you're dividing by. So, probably gonna show through a little bit. Now I'm gonna divide by a negative 1. Because in order to continue with this problem, I really need to find at least 1 0, okay, and then kind of see where I'm at. Coefficients remain the same because this is still the polynomial that I'm looking at and working with. I haven't done anything. I haven't actually found a 0. Very first step, once I get the setup correct, is to bring down that first term, which is a 3. So now multiply. 1 times 3 is 3. Signs are different, so it's negative. Combine, right? So add or subtract. These signs are the exact same sign. So what you do is you add them, and then you keep. I just got like more negative technically. Right here, 1 times 29 is 29. Those signs are the same, so it's positive. Whenever you combine these together, what I get is that would be 13, 2 and 2 is 4, so 4 plus 1 is 53. Now you multiply. 1 times 53 is 53. Signs are different, so it's negative. Now you combine. These signs are different, so you're using subtraction, right? Enter it in your calculator, 74 minus 53, you get 21. And you would keep the sign of the larger. Your calculator will tell you that. And then you multiply. 1 times 21 is 21. So many 21s. Signs are different, so it's negative. What happens here, y'all? What does that become? So yes, awesome, great, it worked. You could write the little notes that I told you to write. I've always done it, and I just think it just really drives home the point that this is what I wanted to find. Because I divided by this -1 and I got a 0, what this means, what this implies, is that -1 is a 0. I'm not trying to say -1 is 0, right? Upper level maths probably prove that because, you know, math is crazy. But I'm saying that as far as this section is concerned with synthetic division, trying to find zeros, if you divide by a number and your remainder is 0, that number is a 0. Like that's what it's called, okay? Now, because I divided by it, I got 0, this further implies, means, says, equals, whatever you want to put there. It means, implies, is that I can write it in factored form. What would that be? A positive one or a negative one? That would be a positive one. This is a factor. And that came from that remainder theorem, factor theorem. If this is what they told me to divide by, didn't I set it equal to 0, right? That 1 moves over. Okay, I'm actually dividing by a -1. These are saying the same thing, but I need it written in this form because the only reason why I'm doing the majority of chapter 3 is to factor things, right? And I've always said factors are sets of parentheses. And whatever your exponent is, that's how many parentheses you have. So now that I know x plus 1 is a factor, what I can do, this is my quotient, right? This is the answer to that synthetic division I just now solved. So what I'm going to do is I'm going to use the fact that I know this is a factor. And I'm going to write the quotient that I just now found. Y'all, you have it on your notes. I probably don't in front of me because it's here. My original problem, right, where I pulled these coefficients to even do this synthetic division, that was raised to the 4th power, right? So once I do get to a point to where I can use this quotient, my degree is going to go down by 1, okay? So now it's 3x, started at x to the 4th, I'm going down 1, so now it's cubed. And then y'all, the rest of the terms that you write, your variables, exponents, just continue to go down by 1. It's going to go 4, 3, 2, 1, none. 5, 4, 3, 2, 1, none. 7, whatever they give you, right? Hopefully it's not too high. Homework can get very crazy. But it just lets me know that I'm probably going to be doing this process multiple times because I need all of my exponents to go away. All of my higher exponents other than 1. So the next term in my quotient was a -29. So that's a x squared. And then I've got a positive 53, and that's just a x. And then lastly, I've got a positive 21, close. The goal has been to find zeros, right? Technically, I did find a 0, right? I've got -1 to 0, but I'm not done. The reason why I'm not done is because when I do factor this problem, I'm going to have all of my parentheses. It started with being raised to the 4th power, so that tells me I've got 4 sets of parentheses. Here I only have 2. Like I'm nowhere near done yet, right? So because I'm finding zeros, y'all, you can go ahead and just set it equal to 0. Because once you do get to a point to where you have it completely factored, what you would do is set everything equal to 0, and you have your zeros, right? Like just their values. Honestly, writing this, you already have your zeros. Okay, like doing that step keeps you from having to do those little bitty equations. Okay, so the answer is no. Do I know anything other than synthetic division to factor this? No. I haven't gotten to a point to where, say it was squared. Don't I know like the square root factor, the square root property, sorry. And then I have like the AC method, then I have the quadratic formula. Do you see that those are always when it's being squared, right? This is being cubed. I can't use those. So basically I need to repeat the process again. This is where the Descartes would really come into play, because it would give you an idea of, oh, it said I have one negative real zero. Well, there's my one negative real zero. When I try more possibles, I'm not going to try any more negative values, right? Because Descartes already told me I only have one negative, and there's my one negative zero. Does that make sense? That's kind of usually how it would come into play, okay? Because it can help you even be able to narrow down your possibilities that much more. You don't have to, though. So I know that what I need to do is synthetically divide this because it's still a high exponent. It's higher than 3. Sorry, higher than 2. So let me go ahead and do that. In my notes, I did Descartes, but it takes a long time. Okay, so I don't know how much room I'm going to take. Once we do get this factored a little bit further and like I kind of rewrite it, we just can't forget that this was here, okay? I don't want to draw an arrow and then I take up too much space. So let's look at this one. Let's synthetically divide. You still use the same possible zeros, okay? And that's because, look, my numbers are still 21 and 3. That didn't change. So let's do it. In my notes, I tried 1, -1, and 3. Just for practice, we'll do 1, and then we'll just jump straight to 3, okay? But at home, you're just trying until you find one. So let's divide by 1. Told you I had hiccups. 3, -29, 53, 21. So bring down your 3. Now we multiply. 1, 3 is 3. Signs are different, subtract and keep the sign of the larger. 126 is 26, signs are different, so it's negative. If you do, what is that, y'all? 1, 3 is 3. Is it 20? What is it? 20? Thank you. I was seeing it backwards. So I get a positive 27. And then, because in my notes, I just stopped. That's why I'm like, oh, y'all, what does that actually equal? So then you would multiply. 1, 27, 27. Signs are the same. It's positive. That's not a 0. Okay. Move on to another value. In my notes, I did -1 because I'm literally solving these in my notes. Like I don't have all the answers. In my notes, I did -1. It also didn't work. Okay. So then I moved on and I tried 3. And that was literally me using my possible zeros. What problem am I on? My possible zeros, and I'm trying the whole numbers first. I don't particularly want to try fractions if I don't have to. You can, it's just multiplication and then add, but like it can get ugly. So now let's try 3. I am using the coefficients from the polynomial that's in that second factor set equal to 0. Bring down your 3, and then you multiply. 3 times 3 is 9. Signs are the same, so it's positive. When you combine, because those signs are different, we would subtract, keep the sign of the larger, and then we multiply. 3 times 20 is 60. Signs are different, so it's negative. And then we combine. Those signs are different, so you would subtract and keep the sign of the larger. In your calculator, literally type in 53 minus 60. It'll tell you -7, okay? So now 3 times 7 is 21. Signs are different, so it's negative. That becomes 0, right? So This implies that 3 is a 0, which further implies if you write that in factored form, you get x minus 3, right? Factored forms using the same value, but the sign changes, okay? Because it's like going backwards on the equation. Is a factor. So, there's a lot more paper in this class than the other one. Let me rewrite things. This is where I was. I synthetically divided again. I had x plus 1, right? So we write x plus 1. I just found that x minus 3 is a factor. Because it worked out to being a 0 for the remainder, I can write this quotient. You look at where I started. When I did this synthetic division, I started here, right? So it was cubed, which means now it's squared. Each time you do it, it's going to go down a degree every single time, okay? So you should have it in front of you, y'all. Your quotient is 3x squared, a negative 20x, and a negative 7. And that's equal to 0 because I'm finding zeros. Okay, so that trinomial, well, one is trinomial, right? We've been working with those. Yes.
Why is the x minus 3
You see here where it says 3 is a 0? The reason why I have the ability to, and I do, write it in this way, the beginning of the homework, I want to find like piece of paper I could just write on, like no big deal. The first chunk of 3.4, right? They gave you, say, this polynomial, and they had it written, it's the same one, I just don't know how to write. This is how the problems originally looked. It was a polynomial, and it said divide by, and it had a factor, not a value, not a number, but just a factor, right? So if you want to do long division, it's, you know, binomials or just polynomials dividing polynomials. You can actually do the division with this. If you want to use synthetic division, which is you just have a value, just a numeric value, not factors, not variables, just a value. What we did was I said we needed to find the 0 to that factor. And so do you remember kind of doing this, a couple different chunks here and there? So if I set that equal to 0 and I solve that little equation, I'm going to add 3 to both sides, right? And then I get 3 cancels, great. That's what I'm doing anyway, so I'm glad that worked out. Equals, now 0 plus 3, signs are the same, add and keep. I get x equals 3. So same train of thought, but kind of backwards. Once in synthetic division, finding zeros, once I divide by something and I actually get a 0, I can say that this number is a 0 and now kind of go backwards. Go back into this form. That's where that came from. Okay. Yay, math. Okay, so now I have the first factor I found, the second factor I found. This is the quotient, right? This came from the synthetic division I just did. I know how to work with this, right? Now, usually with trinomials, you can do the AC method. It just sucks if you try to do it and it doesn't work and you get frustrated and you're like, okay, now I've got to do the quadratic because that will always work. A lot of times here recently, what I've been doing is just trial and error and just kind of throwing it into factors, right? I will always do that when my leading coefficient is 1, okay? Even now, today, I don't have the logic and understanding to just throw it into factors here because that's a 3. So what I did in the last class and what I did on my notes and it's actually do the AC method, okay? Now again, y'all, if that's just 1x squared, hopefully that kind of the trial and error makes a little bit more sense. Because it's not, I'm doing AC method. And the AC method tells me to find my A, which is 3, my B, which is a negative 20, my C, which is a negative 7, multiply A times C, which is 3 times negative 7. 3 times 7 is 21. Signs are different, so it's negative. factors of 21, which we did at the beginning of the problem, right? I get 1 and 21 and 3 and 7. Now, this is where I care that my 21 is negative, okay? When I'm finding the factors, don't really think too much about it. But now, the reason why I'm doing the AC method is so that I can expand that middle term. I'm gonna rewrite the 3 terms into 4 terms so that I can do the factor by grouping. Now, y'all look. I need them to multiply to be negative 21, which means one of them's negative, right? Which one of these sets of factors could I use to get to negative 20? It wouldn't be these, right? It doesn't matter which one of these is negative, you're nowhere near 20, correct? So that's kind of off the table. This is all I have left. Did someone say the 21 would be negative? Yeah, and that's because if I make this negative and I do this multiplication, I get back to this, good. But the reason why I'm even doing this step is because I need these to add or combine, whatever word you want to put there, to my B. And my B is negative 20, right? So if you do 1 minus 21 in your calculator, you get negative 20, which equals your B, which is what we want. Because mathematically, I need to rewrite this, but I've got to make sure like I don't break any laws, okay? And that satisfied both requirements as far as it multiplying and it combining. Oh, I like green. Sure, I'm using a lot of green though. Oh, I'm gonna change. Do whatever I want. Okay, so what we're gonna do now is we're gonna rewrite that trinomial, but that middle term I'm gonna write with these 2 new factors that I just found. So what I get is 3x squared. I'm expanding. I'm rewriting negative 20x as those right there. That's a positive 1. Don't forget your variable. My B had an x, so when I rewrite it as 2 different terms, those also better have an x, or like you broke math, okay? My next term is a negative 21x. Those combine to this, therefore, I'm not really changing anything. Then we have our negative 7. Now, we've done this, y'all, right? And usually I probably wouldn't even go this depth into this, but I do want to make sure that there are a lot of these factoring techniques that y'all do understand. So if I can, I will. And we have time, so why not? 4 terms. 4 terms, factor by grouping. Literally, group the first 2 together, then group the second 2 together. I would recommend do not use parentheses. I just do a little slash. When we have 4 terms and we do factor by grouping, what we're going to do is just a lot of GCF. It's a lot of seeing what they have in common, pulling it out. What I mean by pull it out is we're dividing, okay? If you look at 3 and this coefficient of 1, the only thing they have in common is 1, right? So, I mean, if you wrote 1, that's fine, but you don't have to. Not here because it's like multiplication and division, okay? So if you look at their x's, this has x times x, right? That's 2 x's. This has x, that's 1x. So what they have in common is 1x. Your GCF for variables will always be the lowest exponent, okay? So here we divide. 3 divided by 1 is 3. Signs are the same, so it's positive. Here's an exponent rule. X squared divided by x. The exponent rule says to keep and subtract. So 2 minus 1 is 1. And then scooch on over. Let's do this divided by this. If you do x, y'all, divided by x, don't you just get 1? Yeah. So the thing is, that does need to be placed here. Those signs are the same, so it's positive because it's like a placeholder, okay? I basically just did division. I had a binomial, which is 2 terms, and I divided it by something. So my quotient better also be 2 terms, okay? A lot of people will think, oh, it's math, don't have to write the 1. You do here, okay? You have to do that there. Very important, bring down your negative. Now, when you look at 21 and 7, what is the largest number that can equally divide both of those? 7. See, right? 7. Do they have an x in common? No. So I'm done. That's my GCF. Do your division. 21. I'm so stupid, y'all. Sorry. I feel like I said it like 21 times. 21 divided by 7 is 3. Signs are the same, so it's positive. X divided by no x is technically x over 1, which is just x, right? Okay. There's a part of the division, it'll be a part of the quotient. So 3x, scooch over. 7 divided by 7 is 1. Signs are the same, so it's positive. What you do here is, it's one of two things. Either you can pull a GCF out again, looking at that as one term, and then looking at all of that as one term, right? I've always just said, these parentheses, they have to match. Do they match? Yes, they match. My math was correct. Just write it one time. And then you just can't forget what's left over. Those are two terms that do need to be in my answer, and what you do is you put them in a set of parentheses together. Okay, I feel like this problem's taking forever. I think all problems take forever. So what you end up getting right here, two sets of parentheses. Basically all I did was just factor this, right? Just took a little bit longer because I did the AC method instead of just trial and error. What you get for your two factors goes right here. It's just weird to do my work here and write my answer here, but I just wanted to stay on the same piece of paper, okay? So now y'all, I'm not gonna do these little itty bitty equations, but your zeros, it started with x to the fourth, right? So my goal was to find all the zeros. Because it's x to the fourth, I'm gonna have 4 parentheses. Doesn't necessarily mean you'll have 4 different numbers, because if something repeats, of course, you're not gonna write it more than once, right? But I know that I'm done here because I've gotten to 4 factors. Now, if I set it's equal to 0, right? If I do x plus 1 equals 0, what do I get? -1. If I do x minus 3, and y'all can on your work, okay? I'm not start running out of room and I want to go on. I'm just hoping this still makes sense to y'all because we've done it 3 billion times. X minus 3 equals 0, I would get 3. Let's do this one. X minus 7 equals 0, move that 7, I'd get a positive 7. Then y'all, this one, you would do what's easiest for the first step, because that's a 1 being added. What I would do is subtract it. So now I've got a -1, right? Last step, divide by 3. I end up getting a -1 over 3. Now, if you don't do all of this factoring, which I get it can be not super fun for a lot of people, and you literally just keep plugging in things, I wouldn't off the top of my head think that a fraction is going to be a 0 to this polynomial. Do you see what I'm saying? So like, even though it's long and it takes a while, it's going to be a lot better than you just randomly trying all 8, 10, 12, 14 possible zeros, okay? Or coming up with your own. So the zeros for that polynomial are -1, 3, 7, and -1/3. I really wanted to do another problem. I don't have time to. We're going to start it. I literally completely finished in the first class, and I haven't at all here. Monday, we're going to finish this problem, though, just because I think we need to. So let's just go and get started. This is my polynomial. It says find zeros. First and foremost, what are my possibilities? This one's great. Leading coefficient's 1, right? My p's over my q's means the factors of 10, which are 1, 2, 5, and 10. Factors of 1 are just 1. I get plus or minus 1 over 1, plus or minus 2 over 1, plus or minus 5 over 1. This is why I say having a leading coefficient of 1 is beautiful, because your possible zeros, don't they just end up being your factors of your constant term? So plus or minus 1, plus or minus 2, plus or minus 5, plus or minus 10. I think I did this exact problem, if not this exact one very similar on the videos, y'all, because this one's gonna have to do quadratic formula, so I kind of wanted to do it. 6 minutes. Okay, those are my possibilities. So what I'm gonna do is I'm gonna pick a possibility and I'm gonna plug it in. Definitely for time, In my notes, I did 1, it didn't work, okay? So you move on, just cut your losses. Go to -1. And y'all, I could take a few before you get to an answer, but I think it's usually just like 2 or 3. Coefficients are 1, -4, -1, 14, 10. I want a 0 here. If I get a 0 here, I can kind of move on with the process. If I don't, I got to try another one. Bring down. 1 times 1 is 1. Signs are different, so it's negative. Combine. Signs are the same, so you add and keep. 1 times 5 is 5. Signs are the same, so it's positive. Combine. Signs are different, so we would subtract, keep the sign of the larger. Multiply. 1 times 1 is 4. Signs are different, so it's negative. Combine. Signs are different, so I subtract, keep the sign of the larger. Multiply. 1 times 10 is 10. Signs are different, so it's negative. Boom. Awesome. I got a 0. So this implies what I divided by, my -1. That's a 0. Which further implies that if I write it in factored form, that actually is a factor for this polynomial. So it's like, awesome. Now I can move on with this process. And what I mean by that is I'm going to write this factor, and then I'm going to write the quotient, right? Set it equal to 0, kind of see what I need to do. So I get x plus 1, and then open parentheses. Y'all, it started with x to the 4th. When I write my quotient, it goes down a degree. So I get x cubed, that's a -5. X squared, that's a +4x. That's a +10, close, equals 0. I don't have anything else other than I don't know what synthetic division is, but I have synthetic division, and that's the only thing I could do here, okay? Again, Descartes, if it tells you you only have 1 positive or 1 negative, you kind of know what to plug in here. It's a quick process though, if you get the synthetic division. Let's do it just so I can factor it one more time. Okay, when we come back on Monday, I'll just do a quick quadratic formula to get the final answer for this one. Okay, so synthetically divide. In my notes, I did 2 and it didn't work. I did -2 and it didn't work. I did 5 and it didn't work. And then I was like, okay, I'll freaking do -1, which is usually where I start. I don't know why I didn't, but when I did -1, it worked. So let's just go and do that. These are the coefficients, y'all. This is the one I'm dividing. Okay, not the original problem. I've moved on. I get 1, -5, 4, 10. Bring down. 1 times 1 is 1. Signs are different, so it's negative. Combine. Signs are the same. Add and keep. Multiply. 6. Same positive. Combine. That's just a +10. Multiply. 1, 10, 10. Different. Negative. Awesome. This tells me that that -1 is a 0. Someone asked me a question in the last class. It's unfortunate, honestly, that -1 worked twice. Can you see me? That -1 worked twice because I don't want someone to think that, oh, if something's a 0, I can just assume it can be written multiple times. It can't, okay? You can do a few problems and have that train of thought and just really check and see. You'll notice that's not how it works out. So it just happens to be where my -1 worked twice, okay? So this means that x plus 1, y'all, is a factor. I wrote it up there. Now, because this worked out, I plugged in -1, I got a 0. Here's another factor. Let me rewrite this. I had x plus 1. I just found that another x plus 1 worked. Because I got a 0 when I divided by this, I can write the quotient, which is x started as cubed, now it's squared. -6x, +10, set equal to 0. This is what we'll finish whenever we get back. I'll tell you a story about a boy, which is just a quadratic formula. I just have a really funny way of saying it. And so let me do roll and y'all are free to go. Unless you want to know what your grade is, then I can show it to you on here, okay?